Question about evolution of stars here, but beginning with a link to our energy topic. So complete the table by placing ticks to show whether each energy store increases, decreases, or stays the same as a main sequence star is created in a collapsing region of a nebula. So this is when the dust and gas come together and collapse, forming a main sequence star. So chemical energy store in this instance is going to stay the same. We haven't got any additional increase in the chemical store here. Similarly, the nuclear store is going to stay exactly the same. But what's going to happen here is as all of this collapses inwards, the gravitational potential is going to decrease, and the reason it becomes a main sequence star is because the thermal energy store will increase, and when that then gets hot enough, that's when we get our fusion reaction happening. The property of a star that determines whether it becomes a red giant or a red supergiant, so this is always the mass. The mass of our stars decide which of those two routes they are going to go down. You wouldn't get any credit for the size of a star here because bear in mind the density of stars can vary. So it's really important that you do refer to mass, and you mustn't refer to weight because remember weight is a force. Okay, now we're asked to compare the differences between the red giant and the white dwarf. Now you can choose either one of these to refer to. So I'm going to do it in terms of talking about the red giant. You can of course talk about the reverse argument and talk about the white dwarf. So the first thing to bear in mind is the red giant is brighter. Okay, so the red giant will have a greater brightness. Remember, our red giant, we have still got those fusion reactions going on. So that takes us to our second point, the idea that in our red giant we have still got fusion taking place. Okay, that's no longer happening in our white dwarf because our white dwarf is what remains after all of our fusion reaction has finished taking place. Big thing here, the clue is in the name. The red giant is significantly larger than a white dwarf. Okay, they are great big stars. They are much, much larger than the white dwarf. And actually, the white dwarf, if you remember, is a very hot, dense core that remains, and therefore the surface temperature of a red giant is lower than it is for a white dwarf. So the surface temperature is lower than it is for a white dwarf. As I previously mentioned, that white dwarf is a hot, dense core, so therefore the red giant is less dense than a white dwarf. So that's another option you could have. Do of course make sure you are writing out the full words. So any from that list you need to give 4.